Hey everybody, welcome back. So today we're going to go on and to continue our unit for chemistry. The last couple of weeks we have discussed bonding. Now we're going to go into and actually counting atoms when we are given a compound and being able to distinguish the total number of atoms that we have total in that compound, as well as how many atoms that are present for each element that we are using. So let's get started. All right, so today, this is what we are doing. I'll bring y'all down a little bit so y'all can see. All right, so our topic is counting atoms. Y'all can see just a little bit more. There we go. So counting atoms. Our essential question is determine the number of atoms in a molecule and or compound. Okay. So if you remember a few weeks ago, we defined the word atom. Atom is the smallest particle. You could say particle, unit, part, smallest particle of an element. So that's to say if we have chlorine, or I'm going to go and make a small one because I don't feel like drawing the whole thing. Say we have helium. Here's helium. That is my nucleus for helium. Here is his first and only ring on helium. Helium has 2 electrons, right? That is the atom for helium. Okay, it does get a little bit more complicated in the way it actually looks, because this is the Bohr model that we use to represent one atom. Okay, so an atom is the smallest particle of an element. See, I'm going to put of right here, an element. You cannot get any smaller than that. Now we're going to go down and we're going to define molecule real quick. A molecule, remember, is 2 or more atoms bonded together. They do not have to be the same. So O2, which is 2 oxygen atoms bonded together, is considered a molecule. Sorry, that is an O. As well as NH3 is a molecule. I'm going to do one a little bit. So carbon, that's bonded to 4 hydrogens. It's a molecule. We can also say H2, 2 hydrogens is a molecule because we have 2 atoms or 2 or more atoms bonded together. A compound, however, is 2 or more atoms bonded together if there are at least 2 of them must be different. Okay. So for example, for a compound is H2O. Okay. Though this is called a molecule, we can also call it a compound because we have an oxygen and a hydrogen, which are different, bonded together. Another example is CO, carbon monoxide. That is also a compound. You have two atoms that are completely different bonded together. So remember, a compound and a molecule could be more than two. For a molecule, they do not have to be the same to be considered a molecule. But for a compound, it's two or more atoms bonded together. If there's only two, like carbon monoxide, you only have two atoms, they have to be different to be considered a compound. Where you have three or more, at least two of them must be different. So just like the oxygen and hydrogen here are different, but you still have that second hydrogen. All right, so let's go on. Now we're going to go start talking about different compounds. We have this word subscript. A subscript, let me make sure I want to have a good definition for you so you do not confuse this with anything. So, it is a number set below or above the atomic symbol. Right. So a couple of examples. We just got finished talking about ions. Okay, a couple of days ago we just talked about ions. So if you have, say, calcium, remember we were talking about ions and charges. He has a charge of 2 plus. That is considered a subscript, and it is slightly higher than my atomic symbol. Now on for the one below, for example, for hydrogen gas, we have a 2 that is slightly lower than our hydrogen symbol. So both of these are considered subscripts. So again, so H2O, we have a subscript here for hydrogen, which is a 2. CH4, that's a subscript as well. If we go to, say, ammonia, and we think of the ion for ammonia, we can pretend there's a 1 in front of that positive. We have a subscript up here, as well as a subscript on the bottom. For this note session, we are only worrying about the ones on the bottom. So these right here, these subscripts are what we are concentrating on today. So we're going to practice on counting atoms for a second, because we just identified what we want for subscripts. So we have hydrogen gas. We have H2 right here. That is our chemical formula. To be able to figure out how many hydrogens are present, so how many hydrogens are present, we can do the Lewis dot structure to figure this out. But if we see this on the bottom, this tells me I have 2 hydrogens. So I have 2 hydrogens. I can draw the Lewis dot structure. Oh, I'm so sorry. I just realized I was out of frame. So I have 2 H2. I have 2 hydrogens present. I can draw the Lewis dot structure to check my work. I have 2 hydrogens bonded. So let's go on to methane. So methane, I have CH4. Here is the molecule, the Lewis dot structure for methane. How many carbons do I have? I can pretend there's a 1 here. So I have one carbon. How many atoms of hydrogen? Right here, I have 1, 2, 3, 4 atoms of hydrogen. How many total atoms are present in methane? 4, 5. Total atoms equal 5 because I have one carbon and 4 hydrogen. Now I'm going to do one that's a little trickier. I have acetic acid. This is the same stuff that is in like our vinegar. Okay. So we can look at this chemical formula. We have CH. We have a small subscript here. So let me back up for just a second. If we look at our carbon right here, we can pretend there's a 1 right there. So we have one carbon. I know we have 3 hydrogens here. I have a carbon. Pretend there's a 1 here. I have one oxygen, and 1 hydrogen. This is the actual structure of acetic acid. So I have 2 carbons. I have 2 oxygens. And I have 1, 2, 3, 4 hydrogens. That gives me, so how many total atoms present in acetic acid? So I have 4, 5, 6, 7, 8. Total 8 atoms. So I'm gonna try to make it aware. There we go. All right, now we're gonna move on. I want you to pause the video and I want you to look at this one for a second. Before we jump into it, pause it and see if you can work on this one for a moment. So just propane. Now I'm going to scoot you down so you can see the formula. There we go. So here is our formula. CH, C3H8. How many carbons do we have? How many hydrogens do we have? And how many total atoms are present in propane? This is the molecular formula for propane. Pause the video and see if you can check it. So if I look here, I know I have 3 carbons, 8 hydrogens. So 3, 8, and the total number of atoms present, all I have to do is 8, 9, 10, 11. Total of 11 atoms. So let's check it with my structure. Make sure I read this correctly. I have 1, 2, 3, 3 carbons, and I have 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. Now, each one of these are to be counted. 1, so I have 1, 2, 3, 4, 5, 6, 7, 8. Now let's check. 9, 10, 11. I have 11 total atoms. Okay. Now here's glycine. Let's look at glycine. So here's our formula. Pause the video and see if you can work on this one. Okay, so let's check it. Right, I have a subscript on my carbon of 2, so I now have 2 carbons. I have a subscript 5 for my hydrogens, so I now have 5 hydrogens. I have a subscript of 1 for my nitrogen, so I now have 1 nitrogen present. And if I look at my oxygens, I have 2. So 5, 6, 7, 8. 5, 6, 7, 8, 9, 10. So I have 5, 6, 7, 8, 9, 10. 10 atoms. And I can see I have 1 nitrogen, 2 hydrogens, so that's 3. This right here would be considered a carbon. This carbon is bonded to both spots, this nitrogen, and I have another carbon right here. This carbon is double bonded to an oxygen, single bonded to an oxygen, so that's 1, 2, 3, and he's bonded to another carbon. That's 4 bonds on that carbon. This carbon is bonded to this carbon and this nitrogen, so that's 2 bonds, but he also has 2 H's, so that's where my H's are coming from. So 2, 3, 4, 5, 6, 7, 8, 9, 10 atoms. All right, so now let's go look at sulfuric acid. Pause the video and see if you can do this one on your own. So I have 2 hydrogens, I have 1 sulfur, 4 oxygens. 4, 5, 6, 7. Right? 6, 7 atoms. And I go here, I have 1 hydrogen, 2 hydrogens, I have 1 sulfur, and here are my oxygens. Right? Let's go down and count acetaminophen. So it's acetaminophen, which is our Tylenol, this stuff that you take when you have a headache or your muscles ache or something that you take for a pain reliever, acetaminophen. So let's pause the video and look to see if you can count the number of atoms for carbon, hydrogen, nitrogen, and oxygen in this compound. Okay, so we have for carbon, we have 8 because we have a subscript of 8. Hydrogen, we have 9 hydrogens present, 1 nitrogen present, and 2 oxygens present. If we count all of this up, we have 9, 10, 18, 19, and 20 atoms. 20 atoms are present. 20 atoms are present in one molecule, one compound of acetaminophen. Let's check. That's the actual structure for carbon. So here, that's a carbon, 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 carbon. Oh, and I forgot it. 2 carbons. 1, 2. 1, 2, 3, 4. So this carbon has 4 bonds. He's bonded to this hydrogen, double bonded to this carbon, bonded to this carbon. And that goes all the way around. He has a double bond, single bond to him. So he actually has a hydrogen here. He has a hydrogen, hydrogen, and a hydrogen. This carbon is bonded to this oxygen, double bonded to this carbon, so that's 3 bonds. Single bonded to this carbon, 4 bonds. So that carbon's happy. Oxygen is bonded to this hydrogen and this carbon. He's happy. Carbons are happy because two bonds right here, 3 and 4. Carbon happy, carbon happy. Nitrogen is bonded to this carbon. He's bonded to this carbon. He's bonded to this hydrogen. This carbon is bonded to this carbon right here and the 3 hydrogens. This carbon is double bonded to oxygen and bonded to nitrogen and this carbon. So the further we go into chemistry, we're not going to really mess with anything like this in our class. But I wanted you to get used to seeing that chemistry structures are not just a linear structure like propane. We actually get into a lot more sophisticated and complicated structures as further you go on. All right, so one thing I want to touch on real quick. Okay, I'm going to flip back over to the front part of my page for just a second. I have this methane molecule right here. Okay, I'm going to write out the compound for it one more time, CH4. If I were to take this compound and I put a 2 in front of it, I can have the parentheses there or I can take those away. This was not, I did not really need this, but it's just for making something click that you've learned in algebra. Okay, we're going to cover this more next time, but if I have a 2 here, that means I have 2 molecules of methane. So that means everything that I have inside these parentheses are going to be doubled. So that's what that 2 means. I will double everything in here. So actually, it'll be like this. I will double it, multiply everything by 2. So instead of having 5 atoms, I will have 10, because it will be 2 carbons and 8 hydrogens. So, recap real quick. We reviewed what an atom is. We reviewed what a molecule is. We reviewed what a compound is. Molecule, 2 or more atoms bonded, do not have to be the same. Compound, 2 or more atoms bonded, where at least 2 of them must be different. We learned a subscript is a number that is set slightly below the atomic symbol of an atom, or it can be slightly above atomic symbol of an atom. And then we learned how to count atoms within a molecule and within a compound. So that is it for today. Look out for any assignments that are posted in Canvas, and I will see you next time.